What is C programming? C is a general-purpose, high-level programming language that was developed in the early 1970s by Dennis Ritchie at Bell Labs. It is a procedural programming language, which means that it follows a set of instructions to complete a task. C is commonly used for system programming, such as operating system development and embedded systems programming, as well as for developing applications that need to be highly optimized for performance. C is also the foundation of other programming languages such as C++, C#, and Java. C is considered a low-level language because it can directly access memory, and it is also a middle-level language because it provides constructs that can be used to write high-level code. Here is a step-by-step guide for learning C programming. Get a C compiler. In order to write and run C programs, you will need a C compiler. There are several free compilers available for download, such as GCC, GNU Compiler Collection, for Windows, Linux, and Mac. Learn the basic syntax. Start by learning the basic syntax of C, including data types, operators, loops, and control flow statements. Learn about functions. In C, functions are used to organize and structure code. Learn how to define, call and use functions in C. Learn about pointers. Pointers are a fundamental concept in C. Learn how to declare and use pointers, and understand the difference between pointer variables and the variables they point to. Learn about arrays. Arrays are a fundamental data structure in C. Learn how to declare, initialize and use arrays. Learn about structures. Structures are another important data structure in C. Learn how to declare, initialize and use structures. Practice writing programs. Start writing simple programs to practice what you have learned. Start with basic programs like printing, Hello World, and then move on to more complex programs. Learn about file handling. Learn how to read from and write to files in C. Learn about dynamic memory allocation. Learn how to use malloc and free to dynamically allocate and deallocate memory in C. Learn about advanced concepts. Once you have a good understanding of the basics, you can start learning advanced concepts such as multi-threading, networking, and inter-process communication. It's a good idea to also find some tutorials and exercises to help you practice and solidify your understanding of the language. Basic syntax. Start by learning the basic syntax of C, including data types, operators, loops, and control flow statements. Here are some of the basic syntax elements of C programming language. Data types. C supports several built-in data types, including int, integer, float, double, char, character, and void. You can also create your own custom data types using typedef or struct. Operators. C supports several types of operators, including arithmetic, relational, logical, and bitwise operators. These operators are used to perform operations on variables and values. Control flow statements. C uses control flow statements such as if-else, switch case, while, do-while, and for loops to control the flow of execution in a program. Loops. Loops are used to repeat a block of code multiple times. C supports for, while, and do-while loops. Comments. Comments are used to add notes and explanations to your code. In C, comments are denoted by a / followed by an asterisk at the beginning and an asterisk followed by a / at the end of the comment. Functions. C uses functions to organize and structure code. Each function has a specific task to perform. Functions are defined by keyword, function, followed by its name, parameter list, and a block of statements. Pointers. Pointers are a fundamental concept in C. Pointers are variables that hold memory addresses. Arrays. Arrays are a fundamental data structure in C. They are used to store a collection of elements of the same data type. Structures. Structures are another important data structure in C. They are used to group together a collection of variables under a single name. Header files. Header files are used to include declarations for functions, variables, and other constructs in your program. Data types in C programming. In C programming, data types refer to the type and size of data that a variable can hold. C supports several built-in data types, including int, integer. This data type is used to store whole numbers, without a fractional part. Float. This data type is used to store decimal numbers, with a fractional part. Double. This data type is also used to store decimal numbers, but with more precision than a float. Char. Character. This data type is used to store a single character, such as a letter, number, or symbol. Void. This data type is used to indicate that a function or a pointer has no return type. Short int, long int, long int. These data types are used to store integers with varying sizes. Unsigned int, signed int. These data types are used to store non-negative and negative integers respectively. Underscore bool, underscore complex, underscore imaginary. These data types are used for Boolean and complex numbers. It is also possible to create your own custom data types using typedef or struct. The size of data types may vary on different systems, but the sizes of these basic types are fixed and standardized. Operators in C programming. In C programming, operators are special symbols that perform specific operations on one or more operands, values or variables. C supports several types of operators, including arithmetic operators. These operators are used to perform mathematical operations such as addition, plus, subtraction, multiplication, asterisk, division, and modulus, percent. Relational operators. These operators are used to compare values and determine the relationship between them. They include equal to, equals smiley face, not equal to, smiley face, greater than, less than, greater than or equal to, greater than equals, and less than or equal to, less than equals. Logical operators. These operators are used to perform logical operations such as and, or, and not. Bitwise operators. These operators are used to perform bit-level operations on variables. They include and, or, XOR, caret, not, tilde, left shift, less than, and right shift, greater than. Assignment operators. These operators are used to assign values to variables. They include the basic assignment operator, smiley face, and a variety of shorthand assignment operators such as plus equals, percent equals, and equals, caret equals, less than equals, and greater than equals. Conditional operator. Smiley face. This operator is also called ternary operator. It is used to perform shorthand if-else statements. Size of operator. This operator is used to determine the size in bytes of a variable or data type. Comma operator. This operator is used to separate two or more expressions that are used together in a single statement. Typecasting operator. This operator is used to convert the value of one data type to another data type. Each operator has a specific precedence and associativity that determines the order in which operations are performed. It's important to understand these rules when using multiple operators in a single expression. Control flow statements. Control flow statements are used to control the flow of execution in a program. C supports several types of control flow statements, including if-else. This statement is used to execute a block of code if a certain condition is true, and a different block of code if the condition is false. Switch case. This statement is used to perform different actions based on different conditions. It consists of a switch expression, which is evaluated once, and a series of case labels, each with a corresponding block of code. While. This statement is used to execute a block of code repeatedly while a certain condition is true. Do while. This statement is similar to the while loop, but the block of code is executed at least once before the condition is checked. For. This statement is used to execute a block of code a specified number of times. It consists of an initialization, a condition, and an increment or decrement. Break and continue. These statements are used to control the flow of execution within loops. The break statement is used to exit a loop early, and the continue statement is used to skip an iteration of a loop. Go to. This statement is used to transfer control to a labeled statement in the same function. It is important to use appropriate control flow statements to make the code more readable and to achieve the desired output. Also, it's important to use the curly braces properly to enclose the code block, even if there is only one statement in the block. Loops in C programming. Loops are used to repeat a block of code multiple times. C programming language supports three types of loops. For loops, the for loop is used to execute a block of code a specified number of times. It consists of an initialization, a condition, and an increment or decrement. The syntax for a for loop is for initialization, condition, increment, decrement, code block to be executed. While loops, the while loop is used to execute a block of code repeatedly while a certain condition is true. The syntax for a while loop is while, condition, code block to be executed. Do-while loops. The do-while loop is similar to the while loop, but the block of code is executed at least once before the condition is checked. The syntax for a do-while loop is do, code block to be executed, while, condition. It's important to use the appropriate loop construct for the task at hand and to include a way to exit the loop, otherwise it can lead to infinite loops. Also, it's important to initialize variables before using them in loops and increment, decrement them properly to avoid infinite loops.